All right, so like I said, today we are specifically talking about translations. All right, so every day this week we are going to talk about specifically a different type of subtype of transformation. So yesterday you kind of scratched the surface with it. They kind of threw a little bit of everything at you, but now we're actually going to talk about the actual rules for each. So, and by the way, guys, I am recording this. When you guys get access to Canvas, if you need to rewatch it, it'll be there. Okay. So, when it comes to transformations, there are special types of geometric transformations. The first types that we're concentrating on is the rigid motion. All right. So, like I said, the first three rotations, reflections, and translations are all rigid motions, meaning they keep the same size, keep the same shape. Dilations, which is one of the last ones that we'll learn, is the only one that is non-rigid. All right. And so this maps out rigid motion, aka isometry. So another name for rigid motion, you may hear this every once in a while, is called isometry. And all that means is that they map lines to lines, rays to rays, segments to segments. Meaning everything's the same length, the same size, same angle. Length, shape, and angle, all the same. They preserve the distances between the two map points, meaning all the points are going to be the same distance from their counterpart. And they preserve the angle measures between the two mapped rays or the lines or the segments, depending on if it's a shape. All right. So, in other words, the angle measures. So, for example, if we were given a triangle and one of the angles was 45 degrees, one of the angles on the new triangle would have to be 45 degrees. All right. Now, again, we're talking about translations today, which is a rigid motion. Now, remember how I said we were going to talk about that direct distance between the 2 points? Well, that is what we call a vector. All right. Now, you'll probably hear about vectors in science class. They deal mostly with direction and motion. It's a physics thing. But in geometry, it's really just the direction, the straight line distance direction that a point is going from one position to a next. All right. So a geometric vector, or just a vector, you'll probably just hear me say vector, is a straight line distance in a particular direction. It can be defined by a line segment with a starting point and an ending point. All right. So vectors always have a starting point and the ending point. So in other words, you go from A to A prime, B to B prime, all that good stuff. But with translations, basically the slope. So whenever we're trying to design the vectors, another way you can think about vectors is slope. So you guys recall with Math 1, slope, all that loveliness? All right. How do you typically get slope? How do you? Well, that's slope intercept form. I'm asking, how do you find slope on a graph? Not y over x, but you're close. It would be the difference of y over the difference of x. All right. But it is also rise over run. So when we think of slope, we think of the difference of y over the difference of x, or in other words, rise over run. All right. Now, guess what? This rise over run, the rise is your vertical distance. The run is your horizontal distance. All right. That's the actual translation. So in reality, you're doing the rise over run part for finding the slope of that vector while you're translating a figure. All right. Now, for this one, we are just going to be drawing the vectors. So you always want to signify which is the starting point, which is the ending point. The way that you do that is that you draw an arrow towards the end to kind of map its distance. All right. So if it says that we're going from A to B, that means we're starting at A. So if this is our start point, we're going to go all the way down to B. And I typically draw an arrow right here so I know that that's the direction that I'm going in. With vectors, it's all about the direction. So it's all about that direction. That's what's the difference between a vector and just a line segment. It has a specific direction. It means I know for a fact that I'm starting at A and I'm going to B. Whereas if I just gave you a line segment, we don't know where it started. So if I'm going from E to D, am I going to go up or am I going to go down? Up. So I'm going to start at E. I'm going all the way up to D. All right. From Q to R, am I going left or right? Left. Good. So I'm starting at Q and going to R. So that's pretty much all vectors means. It means that you start at a specific point and you end at a specific point, and that direction that you're going in, that represents the vector. Does everyone kind of understand the whole concept of vectors? And again, if you ever take physics or physical science here, you'll probably learn a bit more with vectors because it's a very what's the word? It's very relevant in physics. I just can't English today, guys. All right, so now let's talk about the actual translation part. So, translation maps is when we move each point on the plane a certain distance in a certain direction. All right, so in other words, all points are parallel to each other. Now, this is defined with a given vector. So sometimes they will not tell you, oh, I want you to go left 5, up 4 or something. All right, they give you a vector, which if we look at example 2, this is our vector right here. It's a little hard to see, but this is the vector right here. They didn't tell us how we got there. They just gave us a vector. So how do you think I'm going to figure out how I got there? Right, you just do some rise over run, but make sure you start at the original point. All right. So whenever you do rise over run, or in this case, it's not even rise over run. You just need to do the rise and the run. All right. So make sure you start at the starting point. Otherwise, your directions are going to be wrong. All right. So take a minute, figure out the translation from A to A prime. All right, thumbs up if you're ready. So when you're finding it, find the horizontal distance and the vertical distance. Just starting at A. It's like you're almost finding slope, but without the actual dividing part. All right. Let's go with sailor. What did you get as your horizontal direction? So left, right. It was right 6. That's what you said? Okay. Yes, that is correct. So you would go right 1, 2, 3, 4, 5, 6. All right. So we say that is shift right 6 units. That's how we properly write it. All right. Let's go with Blake. What was your vertical distance? Right. Down 3. So we go down 1, 2, 3. And we say that it shifts down 3 units. So we can't just say right 6, down 3. We have to actually put the word shift there. We got to put that vocabulary in front of it. We don't have to say it translates that way. We just say shift. All right. Now, given what we know with the algebraic rule, so in other words, if we look from point A to point A prime, what happened to the x value? So the x value from A to A prime, what happened? They added 6. So if I want to write the rule, it would be what? X plus 6. Whereas if we look at our y value, what happened? From A to A prime? Minus 3. So we write this as y minus 3. So when it comes to translations and you're writing a rule, you would write it as addition or subtraction from the original x and y. All right. There's no multiplication in translations. There's no dividing in translations. It's simply addition or subtraction from x and y. So what would be a good strategy to figure out the translation if all I gave you the points but no graph? So if I gave you just A prime and A, and I told you what happened, how to translate, what would you do? So, again, let's say this graph didn't exist, all right? And I gave you those 2 points, so A and A prime. And I said, okay, they translated. Write a rule. How would you figure it out?
Find the difference.
You would take the difference of them, all right? So in other words, you could do 3 minus negative 3. So you would do the new minus the original. All right, that's the way you can figure it out if I just gave you the points. You could do new minus original. So if you're just given points, so just given points, you would do the new minus the original to find how it shifts. Now, if you were just given the points, I will flat out tell you if it's a translation or not. All right. It won't just be like, oh, figure it out just from 2 points. No. I would flat out tell you, okay, a rotation happened here. What happened? A translation happened here. What's the rule? That's how you would see it if that was on a test. Any questions so far? Now, I know you guys can graph the points. Does anyone need to see me actually graph the points? Speak now, forever hold your peace. All right. So if this was on a test, you would also have to graph B prime and C prime, figure those points out. But all you would do is just go to their respective starting points, shift to the right 6, go down 3, and label it accordingly. All right. All right. So, like I said, the general rule here is that if you start with the point xy, x would be plus or minus, um, let's call it a, and y is plus or minus b, where a and b, or where a is equal to the horizontal distance and b is equal to the vertical distance. And if you want to think about it in terms of slope, a would be the run, b would be the rise. All right, that's another way you can think about it. All right. So take a minute and I want you to plot the points for JKL. All right, so take a minute, plot those points for JKL for example 3. Now, once you finish plotting those points, go ahead and do the next part, which is translate 4 units left and 5 units up. And make sure to label it as J prime, K prime, and L prime. All right, thumbs up if you have the image plotted. Now, just says vocabulary. What do I mean by image? Well, it is the triangle, but which one? The old or the new? The new. Pre-image is the old. All right, so if I say image, I mean the new one. Pre-image is the old one. All right. Check your work. I already went ahead and told you what the points are, because I know you guys can identify a point on a graph. All right. Now, here comes the fun part. Now let's talk about how to write the rule. So we always start with the point xy becomes, using that arrow, Now, what would be our horizontal distance? How would I represent that with my x? Yes. Right, you do x minus 4. Why is it minus and not plus? Right, because we're going left, which means we're going down on the number line. So if we look at the x-axis, if we're going to the left, we're going down on that number line. All right, someone else tell me what you would write for your vertical distance. Y plus 5, because we're going up 5. So we're going higher on the number line. That's how you can also tell if it's plus or minus. You could also figure it out from the points. If you look from J to J prime, if you found the difference, -4 minus 0, that's -4. We have a -4 here. 7 minus 2 is 5. We have a plus 5 here. That's another way you can think about it. Now, in y'all's opinion, are these similar or congruent? So put up 1 finger for similar, 2 for congruent. 1, 2, 3, go. Right, it's congruent. Why is it congruent and not similar? Right, they're the same size and shape, so they are congruent. And I'm just going to shorthand it with the congruency sign. So the equal sign with a little squiggle on top. Now, similarity means that it's the same shape, but not the same size. All right, that's the only difference between congruency and similarity. All right. All right, last little thing. So we're not going to worry about the graphing part because you really don't need it because you know how to do it without it. So if you want to graph later, that's great. That's a good way to check yourself. When in doubt, graph it. All right. But let's say we're doing the rule right here. All right. So what's that rule going to be in words? Right. Shift left 3 because we subtracted that 3 and shift down 1 because we subtracted the 1. So if I plug in my points up here for my x and y's and do it at the rule, what would be t prime? Someone who has not spoken today. Take a minute. So for t prime, I would do 0 minus 3 and then 3 minus 1, and that should give me my new point, which that would be what? -3, 2. What would my new u prime be? -1, 3. Good. 2 minus 3 is -1. 4 minus 1 is 3. What about v prime? 2, 0. 5 minus 3 is 2. -1 minus 1 is -2. So it's actually not 0, it's -2. My bad. So this will be 2 and -2. Because we did 5 minus 3, -1 minus 1. So remember, if you're subtracting something from a negative, you're actually making that number quote unquote bigger in a positive sense. All right. Now, something's going on after this. They want us to now do another set of translation. All right. So they then say, okay, now you're going to take your primes and you're going to do another translation, but to the primes. We're done with the pre-image. We're done with the non-primes. But now we're looking specifically at the primes. So it told us to look at our image and perform this additional translation using this rule. So before we even do anything, what's the rule state? What in words, what would it be? Someone different. Yes. Right. You would shift right 3 and then shift down 3. Now, I know it didn't ask you to write out in words, but get into the habit of it, because whenever we talk about anything with functions and transformations, we always want to do the rule of 4, which is graphing, algebraic, numerical, and written. So that is our written aspect. So we have our new points up here to play with. All right. So we're going to use our prime points to find our what we call double prime. All right. So these are all known as double prime. That's how you would say it. All right. So T double prime, U double prime, V double prime. All right. So take a minute and figure out the new points using that rule. So remember, all you're doing is plugging in the x and y of the primes into the x and y spots of the rule. All right, for time's sake, because we're running low on time, check your answer. You don't have to. I know you guys are capable of graphing points, so I'm not worried about that. Now, what do you think this would happen? Would it be congruent or similar to the original figure if we translate it again? Still be congruent, all right? Since we're still translating, it's congruent because we just performed a rigid motion. Now, last tiny thing. This is just a vocab thing, and then you're done. I know we're like kind of right on it. So, if we look from our original triangle to our double prime triangle, this is what we call a composition of transformations. All right. All right, so that's all it is. Okay, and we'll learn more about that when we do more different types of transformations. All right. All right, so you guys can go ahead and pack up. Make sure you put your group folders back in the box. If you did not, your homework for tonight is pages 7 and 8. All right, it's only 5 problems. So pages 7 and 8. That one I will check tomorrow for completion. All right. No.
And then let's do that. Thank you.
Because we didn't get to it, I had you guys watch the video.
You're good. I just like stressed out, and I'm like, do I have to do that?
No, hold on to it. That's going in your journal. That's going in your journal. So your mathematic, your composition notebook.
Oh.
Yeah. So your mathematic, make sure you hold on to that or stick it in your group folder before you leave. Because again, it's going in your journal tomorrow. Make sure you have that composition notebook tomorrow. Have a great rest of your day, guys. No. So it's just 7 and 8 tonight. Okay. Oh, thank you.
Quick question before I leave. You glue it into your pages?
We'll go over that tomorrow, so don't worry about it right now.
Okay, I just want to know.
Yeah, I have to give you guys a bunch of stuff tomorrow for that, so don't worry
I'll
about
be
it.
doing it tomorrow. I'll do homework tonight. So I'm not
Oh, turn in box. You're good. Leatherman?
Yeah.
Yeah, he was the principal before my dad at Havelock High School.
That's
So
my granddad.
he's your grandfather? He knows my dad really well because he was the principal before my dad.
Yeah, I talked to him yesterday. He said
Yeah. Do you mind putting that folder into the box for me? I think they forgot. Thank you so much. Danny, right?